In this video, we're discussing tolerance word problems. This is an application of absolute value inequalities. There is a formula that we'll be using, the absolute value of actual minus ideal less than or equal to tolerance. And I'll explain what that means. Look at example 3 with me. A carpenter is using a lathe to shape the final leg of a handcrafted table. In order for the leg to fit, it needs to be 150 millimeters wide, allowing for a margin of error of 2.5 millimeters. So that means that it needs to be 150 millimeters, but it's okay if it's 2.5 millimeters more, and it's okay if it's 2.5 millimeters less, but it cannot be any bigger or smaller than that. Write an absolute value inequality that models this relationship, and then find the range of widths that the table leg can be. Okay? So in our formula, we've got actual, ideal, and tolerance. Okay? Actual is what the table leg actually comes out to be when you actually make it by hand. It could be anything. It might come out to be 170 millimeters wide. So we're going to let X equal the actual table leg width. The ideal is what we need it to be. We want it to be 150 millimeters, so that's ideal. Okay? This margin of error of 2.5 millimeters, that's our tolerance. It can be 2.5 millimeters more than 150, or it can be 2.5 millimeters less than 150. But if it goes outside of that, we've got to just throw it away or go back to work and keep working on it some more. So the tolerance is the 2.5. So putting this into our formula, we're going to have absolute value of X for actual minus ideal is 150. It needs to be 150 millimeters. And the absolute value needs to be less than or equal the tolerance of 2.5. So that's how we can get it into our absolute value inequality. Then they ask us to find the range of widths that the table leg can be. So to get that value, we're going to apply what we know about absolute value inequalities. This is the absolute value less than a constant. So this means that we need to set it up as the opposite of the 2.5. So negative 2.5, less than or equal the inside of the absolute value bars, X minus 150, less than or equal the constant 2.5. So this means that that X minus 150 has to be between negative 2.5 and positive 2.5. And if we continue solving this, we need to isolate X, so we'll add 150, and we'll do it to all three sides. So negative 2.5 plus 150 is 147.5, less than or equal to X, and then that's less than or equal, that cancels, 2.5 plus 150 is 152.5. So this is the range of values, and then this is the absolute value inequality that applies to this situation. And if you go back and look at the original problem, it makes sense. Even though we had to go through the absolute value inequality to answer the question, if you go back and read the problem again, 150 plus or minus 2.5, that would be a minimum of 147.5 and a maximum of 152.5. So that's exactly what we came up with after we went through our work. So that's that's example 3. And then let's look at example 4. A manufacturer allows a maximum of 16.6 ounces of cereal and a minimum of 15.4 ounces of cereal per box. Write an absolute value inequality that demonstrates the manufacturer's constraints. So this time they gave us a minimum allowed and a maximum allowed, but we cannot go outside of that. So we'll still let X be the actual. So when that cereal box is made, whatever it's got inside it, that's going to be actual. Ideal, it has to be in between these numbers. So for ideal, I'm going to basically find the midpoint between these values. So I'm going to add them together and divide by 2. Or really, I guess you're finding the average. You're finding the mean of these two values. So we're just looking for the halfway point. So we want 16.6 plus 15.4 divided by 2. That would be 16. So our ideal is 16. That would be the perfect situation, halfway, but right in smack in the middle of all the possibilities. And then the tolerance is going to be the distance between the ideal and the maximum allowed and the minimum allowed. So that would be 16 plus let's see. No, I'm sorry. So to figure out this, we want to look at the maximum allowed was the 16.6 minus the ideal would be 0.6. Okay, and if you did the 16 ideal and then you subtract from the 15.4 minimum, so 15.4 minimum minus the 16 ideal is going to be negative 0.6. So that means our tolerance is going to be plus or minus 0.6. So we're going to go to the formula. I'm not going to worry with the plus or minus when I write it in though. So I'm going to fill this in. Let me scoot this up a little bit. Okay. So I've got absolute value, actual is x, minus ideal is 16. And the absolute value of that difference must be less than or equal our margin of error, or our tolerance of 0.6. And we were just asked to write the absolute value inequality that demonstrates the manufacturer's constraints. So we've done that. So that's our answer.